Over the past few days, videos like these have gone viral across Indian social media, showing battery operated e rickshaws being disabled and stranded in the middle of the road using a simple Bluetooth app known as BatBMS. So, what exactly is going on here? Is this some kind of malware or hacking software, as many people are claiming? Is it an intentional feature of electric rickshaw batteries, or is this simply a security design flaw? In this video, let's break it down and see what embedded developers can take out of this incident. So, what is a BMS? The most crucial part of any electric vehicle is its battery, and along with it comes the BMS or battery management system. Think of the BMS as the battery pack's personal assistant. A battery pack is made up of multiple individual cells, and BMS continuously monitors the voltage of every cell, controls the charging discharging MOSFETs, performs cell balancing to keep cell voltages within a safe range, and even help estimate the battery's charge level, or SoC in technical terms. On top of that, it provides essential protection features such as overcharge, over discharge, overcurrent, short circuit, and temperature based protection, helping keep both the battery and the vehicle safe. Now, you might be wondering why put Bluetooth on a battery management system in the first place. Well, the answer is convenience. A modern BMS collects a huge amount of useful information. Mechanics and even vehicle owners often need access to this information during diagnostic and maintenance. Instead of opening the battery enclosure every time and connecting a wired debugger, Bluetooth provides a quick wireless interface. Open an app, connect to the BMS, and all this information becomes available instantly. So, in a typical Bluetooth setup, the smartphone acts as the client while the BMS acts as the server. The BMS exposes different Bluetooth data fields, technically called characteristics. Think of them as individual pieces of information or controls that the mobile app can access. Some characteristics are read only, such as voltage, current, or temperature, while others may allow configuration changes or control of certain BMS functions. So, what likely went wrong? Well, Bluetooth itself isn't the problem here, nor is BatBMS application any kind of hacking software. A likely explanation is that the Bluetooth interface exposes controls for the BMS discharge MOSFETs. If those controls aren't protected, someone nearby could potentially disable the battery output, causing the e rickshaw to stall in the middle of the road. So, is banning this app a solution? Well, the BatBMS app was developed by a Chinese company as a companion application for monitoring and configuring certain low cost OEM battery packs over Bluetooth. Following the recent incident, the app has been removed from major app stores in India. If BMS exposes the same Bluetooth interface without proper authentication, another application can be developed to communicate with it. In other words, the real issue lies in the security of the embedded device, not the existence of a particular mobile app. In many applications, Bluetooth doesn't even need to be part of the BMS in the first place. But if wireless connectivity is indeed required, then configuration changes should at least require strong authentication. So, first of all, at least secure connection should be preferred over legacy connections, which provides superior encryption, and after that, the pairing method should be chosen. For that, we have passkey number or numeric comparison methods. An even better approach is to use out of band pairing, where the passkey or pairing information is shared through a QR code or an NFC tag available on the battery pack. Since accessing the QR code or NFC tag requires physical access of the battery enclosure, only the vehicle owner or an authorized mechanic can establish a trusted Bluetooth connection. But why would an e rickshaw manufacturer allow something like this to happen? Well, the answer is often cost and simplicity. Many embedded products are built for highly price sensitive markets, where every additional component, development hour, and testing cycle increases the final product cost. In many cases, vehicle manufacturers aren't designing the BMS hardware or firmware from scratch. They source batteries, BMS modules, motor controllers, and other electronics from OEM suppliers and then integrate them into the vehicle, focus on assembly and distribution. As a result, the security of these off the shelf components isn't always thoroughly evaluated. If the supplied BMS already includes Bluetooth with weak security, that weakness can make its way into the final product. And this isn't unique to e rickshaws. The same supply chain model exists across consumer drones, smart home devices, wearables, IoT products, and countless other electronics, where ready made modules are integrated to reduce development time and cost. There's nothing wrong with using off the shelf hardware, but manufacturers still share the responsibility of at least inspecting the hardware and ensuring that the components they integrate meet appropriate safety and security standards. Incidents like this remind us that the cost of poor security can be far greater than the cost of implementing it correctly from the beginning. As more embedded products become connected, security is becoming just as important as hardware and firmware design. The real lesson is that convenience should never come at the cost of security. If a wireless interface can access a safety critical function, it must be protected with strong authentication and proper access control. As embedded engineers, we don't just design circuits and write firmware, we design systems that people trust with their safety. And in today's digital world, security is no longer an optional feature. It's a fundamental part of good engineering. If you found this breakdown useful, do like and share this video. Subscribe to the channel for more engineering content. This is Avinashee Tech signing off.